In the last video, we discussed about implicit functions and we did few problems based on implicit functions, correct? The derivative of implicit, that's what I mean. Now, in this particular video, we'll discuss about how to find the derivative of inverse trigonometric functions. Fine. Now, just a recap of what is inverse trigonometric function. See, whenever we talk about inverse trigonometric function, you know that the domain and range is gonna change, isn't it? In a sense, compared to the trigonometric function. This is the first part what you should know. In the sense, suppose if you have a function, say y is equal to sine of x. The range and domain of x and y we can easily calculate. That means here the range is basically the values what y will take, correct? And domain is the values what x can take. So x belongs to R, whereas y belongs to the set from -1 to 1, isn't it? Now the next thing what we have is, suppose if you have to calculate the derivative of an inverse trigonometric function. So what we'll do now is, see, you have y is equal to sin x, but that's not really required what we have, correct? So let's derive the derivative of an inverse trigonometric function right now. Let's assume that f of x is equal to sine inverse of x, right? That means we have y is equal to sine inverse of x. Or can we directly say that x is equal to sine y, right? This is normal inverse trigonometric function operation, okay? Nothing more, nothing else. Differentiate with respect to x. That means the LHS is going to become 1, derivative of x is 1, is equal to cos y into dy by dx. Remember how we did implicit functions? Pretty much the same. Now what do you get? Dy by dx is equal to 1 divided by cos y. See, when we have 1 by cos y, we have to represent sine in terms of cos, correct? Now, the reason is we have y is equal to sine inverse of x or x is equal to sine y. Now, if you represent sine in terms of cos or cos in terms of sine, whatever, in this particular case, we have to understand how the equation is going to be. So, when you're representing cos in terms of sine, then we have a particular identity. If you remember, we have a trigonometric identity, cos square x plus sine square x is equal to 1. It's a very, very important identity. So what we can write here is cos x or cos square x is 1 minus sine square x. So cos of x will be root of 1 minus sine square x. Please be careful, do not cancel the sine square and the root. Okay, that is not possible. Mathematically, that's incorrect. So cos of x is equal to root of 1 minus sine square x. Likewise, here y dash will be 1 by root of 1 minus sine square y. Now, what is sine square y? Sine y, we know it is x, isn't it? We have already done it here. See this? Sine y is equal to x. Since we know x is equal to sine y, sine square y is going to become x square. That means at the end, we will get y dash is equal to 1 by root of 1 minus x square. This is going to be the value of the derivative. So, if you have f of x as sin x, then f dash of x is 1 by root 1 minus x square. Fair enough? Now, like this, we have, a one particular table for all the trigonometric, as in inverse trigonometric function. Now, one thing I want to specify here very, very clearly, every inverse trigonometric function has a particular domain value. Like x belongs to one particular value to one particular value. Like in this particular case, x can never be more than 1, isn't it? In other words, what we write is x is a value which lies between -1 to +1. To be honest, it can't be equal to also, because 1 minus 1 is going to give you 0, right? So we always say it is a strict inequality rather than a slack inequality. So even this will not come. It's always between -1 to 1. Understood? So this is basically for sine inverse function. Now, what you're seeing now in this particular table, this is for all the 6 inverse trigonometric function. I want you to look into this particular table very carefully. The reason is every inverse trigonometric function, you have the derivative, correct? And how the derivative, like how do we get the derivative? That is very similar to the one what we just did right now. Okay, like how you took f of x as sine inverse x. So y is equal to sine inverse x. That's how you did, correct? You can do the same thing for every inverse trigonometric function what you're seeing in the table. And all of them, they undergo the same principle. And everywhere we use the trigonometric identity to get the formula. Understood? Now, in the next video, we'll recap certain formulae and certain concepts what you have used last year. That is the multiple submultiple angles and one trigonometric function in terms of other. Like if you're representing cos 2x in terms of tan x, how do we write it? The reason is there are certain problems this year in this particular part of derivative where you might have to use such formulas. So just to recap, in the next video, we'll do the concepts what you have learned last year in trigonometry.